Hey guys, this is Miss Garner, and this is our first video for the Transformations unit, where we will be covering translations and reflections. So the first movement that we're going to cover is a translation. All this means is that we're going to be sliding an object in a certain direction and a certain distance. So notice when we slide this object, the shape isn't changing, the size isn't changing, and which way it's facing, so its orientation also does not change. A couple things to note is that the pre-image is going to be our first shape. So I'll often put a 1 in there. And our image is our second shape. That's the one that it's been moved to. So a way that you can tell which one is which is the pre-image will have our regular letters. So A, B, C, D. Our image, or the one that's the second one, notice they have these little prime notation. It's called prime, but it looks like this, A with a little dash after it. Anytime you see those little dashes, you know that it's the second one. That's where it's been moved to. So where we can see translation in the real world, you'll see it a lot with architecture, or if you're into construction or building things. But a couple more examples are in a honeycomb, each of these hexagons have been translated right to the side. That's what creates those rows. So it's the same shape, it's facing the same direction, it's the same size, it's just been repeated next to it. Another example is seats in a stadium. So if you're a company and you're manufacturing those seats, you only have to do it once. You create the seat and then you just repeat it and slide it to the side. Repeat it, slide it to the side. Those seats are the same size, same shape, and they all face in the same direction. So a translation is an object where nothing changes except it's just been slid over. It's been moved to the side. Okay, so what I want you to do is, what is another example of a translation in the real world? You're going to use a sticky note or a text box or the drawing tool to put your answer here in the red box. On slide 3, we have our first example of how we're going to describe a translation. So as you can see in our picture, we see that that shape has moved, it's been slid, and we're going to describe it by saying what direction and how many units has it slid. So first, let's note that the bottom right-hand side is going to be our starting shape. I know that because look at the regular letters, A, B, C, D. The second shape is up here in the left because it has these primes, those little dashes after the letters. So I know the direction that it slid is like that. In order to figure out the direction and how many units, I'm going to pick a single point. So for this time, I'm going to go ahead and just pick A. I'm going to pick a single point, and I'm going to pick that same point in the new shape, so A prime. I'm going to go along the lines of the grid and count how many units in what direction I had to move to go from A to A prime. So I went 1, 2, 3, 4, 5, 6 units to the left. And I had to go 1, 2, 3 units up. So to describe this translation, I can say that the shape was slid 6 units left and 3 units up. You can do this for any of the letters. You can choose B, C, or D, and it's still going to be that same thing. You can also go in the opposite direction. You could have gone 3 units up to start and then 6 units left. And once again, you're still going to end up in that same spot. Slide 4 and slide 5, you are doing the same thing. So you're going to figure out which one is your starting shape, and then you're going to pick a letter and count how many units and what direction until you get to the same letter on the next one. On slide 6, they have given us a single point, and they're wanting us to translate it. So the point is A, -7, -3, and that's just its coordinate point, right? That's where it's starting at right there. They want us to translate it 1 unit left and 8 units up. So I'm just going to follow those directions. I'm going to start at A, and I'm going to start by going 1 unit left, and now I'm going to count 8 units up. 1, 2, 3, 4, 5, 6, 7, 8. that is going to be where my new point is. So that new point right here, after A has been slid 1 unit left, 8 units up, we're going to call it A prime. On slide 7, you're going to do the same thing. This time we're translating 4 units left, 11 units down. But because you have a shape, you have to do it 4 times. So you're going to do it to each point. So start at S, go 4 left, 11 down, put your point down. Now you're going to do it to P. Go 4 left, 11 down, same thing. R and Q, you're just going to keep doing the same thing. Go 4 units left, 11 units down. Once you have your 4 new points, connect them and you will have that shape that has been slid the direction and the number of units that they want you to. Our second movement that we're going to cover is a reflection. A reflection is just a flip. So you can think of this as flipping an object or folding a piece of paper over a reflection line. So once again, the shape does not change, the size does not change, right? You still have a triangle, same size. What does change is which way it's facing. Okay, so if we look at our 2 examples here, the one on the left, notice that this triangle has flipped over that vertical line. Or you can think of folding it. So you can fold it hot dog style. You're folding it upwards like that. Our second example, notice that it's flipped over the X line. Once again, you can fold that piece of paper hamburger style along that X axis so that those 2 shapes match up. So translate was a slide, and now reflect is a flip. So a couple examples of reflection in the real world. The most obvious is a mirror. So when you look in the mirror, you're seeing a reflection. There are also lots of examples in nature. So a snowflake, butterfly wings, a diamond, the reason it sparkles is because they have those reflection lines. Those reflection lines cause those things to look beautiful. So anytime you have a mirror image, we call that symmetry, and that's an example of reflection. So what I want you to do again is write down an example of where you see reflection in the real world in this red box here. On slide 10, we will be describing this reflection. And in order to describe the reflection, all we have to say is what axis did it flip over? So in this case, my starting shape is on the right. It has those regular letters A, B, C. And my second shape is on the left. So I see that it's flipped like that. The line that it's flipped over, I'm going to go ahead and put it in blue, is this right here. So notice that blue line is the one that it's flipped over. You can also think of that blue line as where you would have to fold the paper so that those triangles are on top of each other. I see that this is the y-axis. That's the axis that it's flipping over. So my answer here is that this is the y-axis. That's the only thing you have to do to describe a reflection. Our second example, same thing. Our starting shape is this one at the top, the blue one. Our second shape is this one at the bottom, the red one. So it flipped in this direction. And if I were to put that line down where it flipped, it would be this blue line right here. That's the line that it's flipping over. And this, of course, is the x-axis. So your horizontal line, remember, is your x-axis. So if you're describing a reflection, you're just choosing between the x and the y-axis. Remember, your y-axis is vertical. Your x-axis is the horizontal. Number 8, you are going to be doing the same thing. On slide 13, we're going to actually be doing the reflecting ourselves. So in this case, they want us to reflect over the x-axis. You will see that they've already highlighted it that purplish blue. What you have to remember when you are doing the reflecting yourself is that the original point is the same distance from the reflection line as the new point. Okay, so I'm going to say that one more time. The original point is the same distance from the reflection line as the new point. So all I have to do is I have to count how far is D from my reflection line. I see that it's 1, 2, 3. It is 4 units above it. That means my new point is going to be the exact same distance on the other side. So it's going to be 1, 2, 3. It's going to be 4 units below it. So my new location for D, which is what I'm going to call D prime, is going to be right here. So once again, you can see that this D has flipped over the x-axis. Your last slide here is the same thing, but you're reflecting an object. So this time we have a square. You're going to do the same thing, but you have to do it to all 4 points. So for instance, T is 2 units away. So I have to go 2 units on the other side. That's going to be T prime. U is 1, 2, 3, 4, 5, 6, 7, 8 units away. So U prime is going to be 8 units on this side. Okay, finish up doing that to the next 2 points, connect them, and you will see that that whole square has flipped over the y-axis.